Good day, everyone. Welcome to this presentation. Today, I'm going to be giving you a brief speech about software modeling and software measurement in the industry, for example, in the games and software development in small companies, large companies, and all together in all types of software businesses. Unfortunately, because of the topic modeling, I also have to be talking about the measurement practices and quality practices, and also about the organizations and what they want to achieve with the modeling and measurement and other practices. But I'm going to be coming into this topic in a few minutes. Right now, I'm trying to give you a 1-hour speech. So, of course, I'm going to be going overtime like in almost all academic presentations. But I'm going to be talking to you not from the viewpoint of academia, but give you an idea from the viewpoint of software industry. Me personally, having been working with the Finnish Software Measurement Association for several years, I have gained insight into how software organizations think, hopefully, at least because I did my dissertation work on software testing and quality assurance practices in software industry. And especially because of this reason, I have been invited to give you this brief talk. So without further ado, let's go to the topic and see what we have prepared for you today. So, as mentioned, the topic of this speech or keynote or visiting lecture, whatever you want to call this, is modeling and measuring in the software industry. The reason why I'm going to be talking also about measuring and also related to quality is that usually the software industry considers modeling work or prototyping work or even design work from the viewpoint of practicality. So what is useful to them? What is useful information? What is worthwhile and meaningful activity? And this consideration is also because the companies usually have limited amount of resources, money or time to do things, and they also gather their requirements with several different ways. And of course, finally, the scope of the project pretty much dictates if the organization is going to do requirements analysis work or pre-development or prototyping or proof of concept prototyping or heavy modeling work, and also what the organizations want to achieve with their design or product they are developing. If they are launching a new product line or creating new components for existing product line and using existing core assets on top of which they add new modules, of course, that means that they might want to do more modeling work, and especially if they are replacing the core modules, they definitely need to do some modeling work to ensure that their product line stays intact. But whereas if they are just developing a throwaway app, for example, event or something like that, they don't really need to do that. But let's start with the fundamental aspects. So, of course, this being aimed towards master's level students, this is something that I really probably don't need to define in very detail. But of course, when we are talking about software development or systems development, it means that whatever we are doing, whether it's a product or service or whatever it is, it's a set, basically it's always a set of components which have a set of objects, and these objects are connected to each other and the components are connected to each other. So of course, if we want to do modeling work, or if we are in general doing modeling work, it means that we want to design how these software's systems connect to each other, how they connect to what sort of information they exchange, what sort of components there are, so that we can actually design something that can be maintained, that can be replaced, that can be measured, and that can be fixed if something is broken, or updated if we need to, for example, exchange platform or exchange our cloud solution or database solution or whatever, or just if we want to tailor our user interface components for a new client. So basically the design aspects and modeling aspects come into play on the design of components. If we have a project or situation where we need to do the modeling work, and if it's something that actually is demanded or something that in the long run will improve our business aspects of software development, then it will be definitely done. Otherwise, we might want to go forward with the prototyping work, but in any case, when we are talking about software systems, whether they are services or products, we are talking about a compilation of components which have objects which form a software which communicates via interfaces with other software systems, making something that produces a meaningful service or product and activity. So in general, of course, this means that when we are building something, we will probably build things, modules one by one, and when we are doing integration, we also need to consider how we will test these things, how we will do quality assurance on these things, and especially after the acceptance testing where everything exists and runs, we enter into the phase called software maintenance. And if we have a model, if we have clearly defined architecture, if we have components which are interchangeable or which are easily separatable from the existing system, then of course we can easily do revision work, re-engineering work, replace these parts like any component or one part from something like combustion engine from car. But in general, if we are a software company and we have a product or service online which is sold to customers, delivered to customers and used with customers, we also need to think what are the most important ways of ensuring that these components work together, measuring how good these components are, where we are going to be using our maintenance budget, where we are going to be focusing on our maintenance cycles, what are the new features we are going to implement, and so on and so on. And of course, this incorporates the aspects of modeling or doing a prototype design work, or designing or doing prototype design work. So how we want to use our effort, what is needed, and how are we going to solve, for example, the problem of offering new features or new abilities or new activities for our customers with our service or our application or whatever we are doing. So considering that, of course, on most courses in academia, if we are talking about designing work or modeling work or prototyping work, it's on this software lifecycle, the part where we do a specification and we have some sort of design. Based on that design, we do a modeling work, we draw the initial architecture, we do perhaps even small prototyping work to test out the ideas. Then we do the development work, do quality assurance and quality control practices. If we find that something doesn't work or we are doing a highly iterative approach, then we might alter the design, do further development, and go back to quality assurance and so on and so on. And of course, realistically, this is how, for example, additive iterative methods such as Scrum or continuous models actually work. We have a grand architecture or roadmap, and we have a set of new abilities or attributes or requirements or components or activities which we implement. Then we add them to existing work, see it works, and if it still keeps working, we add new things. If something breaks down, we either roll back into the previous version or spend some time doing maintenance and fixing work parts we have so far, and abilities and attributes and actions or things we have already implemented. But of course, when we consider the traditional software engineering, we usually have the idea that we implement everything and then put the software available. Of course, this no longer is actually true. On almost all software industries, especially on those which offer software as a service, the initial launch version is something that's the most core abilities, most basic functionalities we can give to our customers. And if we see that this works, then we might want to add new features, add new content, or if some service becomes a huge hit, like for example Netflix did, or Uber became a huge thing, then we might actually even re-engineer the entire back end of the system so that it can actually deliver performance needed for the new customer base. Of course, this doesn't always happen, but to ensure that we can actually do these things, we have to have the design, or we have to have the separation of different activities, front end, back end, components, and so on, so that we actually can switch out one faulty or underperforming part of the product or service while the system is running, and test out the new part, for example, is more regional markets. And this is, of course, something where modeling and service modeling, system modeling, and design work comes into play. So, of course, considering that these are more or less the most common things that might be broken in a software system. So there's a frequent failures. There's overly complex structure. We end up running in emulation mode because we can no longer revise and update our system to match the current existing platforms. We end up with huge components which have just addition after addition after addition after addition. And we also have a number of other process-related problems, personnel issues, documentation issues, and so on and so on. So of course, immediately we can say that these are the things that usually the software projects run into when they get a bit older. So the system decay means that we no longer keep up with the technology race, and we can actually no longer, for example, use the most recent version of the platform or the development environment or the running environment or the operating system or the mobile platform or whatever. But actually, what this also means that to fight these issues, of course, the system has to be maintainable. And if we want to do something that's maintainable, we have to do something that we actually know how it functions, how it works. For example, with the modeling practices, or at least doing a overview model of how the system should work, where things are deployed, how we will implement when and things and where different implementations will exist, what is done by which component. This, of course, means that things like overly complex structures and very large components are easily mitigated by having some design before just making things work. So overall, there is a real need for doing modeling work, doing design work, doing at least architectural model or overview or general model for the system so that we know how the system behaves or what component is responsible for what activity. And of course, even earlier when we are implementing the system, each developer or party knows how the system is supposed to work, how the system is supposed to be built, so that it's easier to ensure that it actually does what it's required to do. So overall, if we are considering the need for modeling or need for using modeling practices or need for ensuring that the system actually is something that we can maintain, we also need to talk about quality. So, of course, the software companies do not actually do anything without a reason, whether it's to save money or make money or ensure that they get the optimal amount of work or, well, effort out of everything. Organizations want to have a ability to see inside their system, to understand how it works, is it working, and how well all the different components are done. And for this, quality is one of the main concepts that needs to be understood in this context. So, from the previous list of software systems becoming old and decay issues, there's basically three things that stick out. There's technical issues. Old software tends to become bloated and full of less than ideal fixes to keep the system running. There's management issues that the process leaks brains and the documentation is not properly maintained, so the new people don't actually understand how the system works. And of course, there's the quality issues because we no longer have the ability to get the optimal usage from our platform, or there's some conflicts or issues with the hardware we are running using as the basis or platform for the system to run. The performance gets weaker and the overall quality declines over time. So, of course, the management issues is not something that we can actually address with the software modeling practices. But for example, technical issues and quality issues are something where we can actually benefit by doing modeling work, doing measurement work, and trying to increase the understanding of the software system, how it's built, how it functions, and what should be going on inside the system. So let's start with the quality. So how can we measure it? How can we say how can we say that something has declined too far? For example, how do we define quality in software systems? How can we say or understand that this is no longer good? We need to define how it works and replace this component because this is the thing keeping us down. So of course, we also need to understand that modeling practices or measurement practices or quality assurance practices or doing work towards quality is something that organizations of course do because they need to do it to stay competitive. But also we at the same time need to understand that from the software industry point of view, all these practices are just money spent on ensuring that the system is something that's still beneficial for the organization. So on this graph, there's the general idea on how much money the organizations will invest to keep software quality acceptable. Of course, modeling practices and measurement practices play into this directly because modeling and measurement are both activities which are done to understand the system, to ensure that the software maintainability stays high, or when we are developing the first product, ensures that the system is built correctly in time with the intended features and it's high enough quality. So from this graph, you see that there is actually a couple of interesting breakpoints. Of course, we need to spend enough money to understand the system so that it becomes useful. And if we are an organization which is dependent on selling this service or product, we also need to be competitive. But however, if we are going way overboard, we do excessive quality, meaning that in theory, we are throwing away money after the saturation breakpoint, doing unnecessary extra work. Of course, what is unnecessary extra work from the viewpoint of the organization varies greatly. If we are doing a operating system, for example, as Microsoft and Apple have and some other companies for embedded systems are doing, the saturation point for excessive quality practices, including modeling and measurement and saturation of how the system behaves, it's very high. But on the other hand, for some other organizations which do simple mobile applications or games, the saturation breakpoint is actually very much lower because they don't necessarily need to ensure that everything works always correctly to stay competitive. Their competitiveness is somewhere else, like reactiveness to the market, or how quickly they can put out their product, or how well their products match the expectations of their clients. These are not some things that we can fix or observe with modeling practices. They are measurement practices, activities, and of course they also explain why some industries, some organizations are not very interested in doing modeling work or design work or documentation work any more than what is absolutely needed to get the system done and out for the customers to use. Also, if we want to consider what sort of things we want to or could measure, these are from the software quality standardization, different types of quality characteristics. Of course, if we are modeling our product or doing measurement work to understand what sort of things we want to measure or model, there's actually several different things, like with the buildings and their building plans. There's the electricity plan, there's the architectural plan, so on and so on and so on. Also with the modeling work, there is an aspect of how we are trying to explain the system behavior. There's a different quality attributes, there's different things in general. For example, the UML2 has 13 different ways of modeling or making a diagram out of your product or out of your software system. So which ones are the most appropriate for us to do? Because creating all the 13 models or measuring all these quality attributes, in addition of these attributes, which are about quality in use, would be insanity and just waste of money. So of course, the organizations need to understand what is the important quality for their organization, what is the important measurements for their organizations, what is beneficial information for them, and this also dictates how they are going to be doing their maintenance practices, what's going to be the reuse of the existing components, and how much modeling work do they want to do, or architectural modeling work do they want to do to pre-plan things so that they can actually reuse the modules or replace modules when they need to do maintenance. And what is the life cycle of the product? If it's the life cycle of one mobile platform, about 1, 2, 3 years, then there's no problem, because there's probably not going to be a situation when we need to transfer our product to another platform or upgrade it to another mobile system or operating system. So we don't need to create very sophisticated system or layers on which we just replace the hardware, the one nearest to hardware, and then we are golden and can use the system again. Of course, this needs money, this needs expertise, and also if it's not necessary, then it will not be done. So overall, organizations don't have a very clear view on what is their preferred quality. Of course, this is also a good thing, because it means that in most organizations there are people who are paying attention to different things. So one person from the things about the security aspects, one about the compatibility aspects, one about the transferability aspects. Some are worried about reliability or performance, and so on and so on. But this, of course, also means that if we are measuring something, or if we need to know some information on how the system is working, how the system should work, and what sort of system we want to build, it means that we need to do the definition work. We need to define the architecture. We need to define the basic models, the basic principles on how the system will work, especially if it's something more complicated than just a standard Android Studio project application with fairly typical deployment package approach. We need to do the definition work and modeling work and the design work so that everyone actually knows how the system will be done. And of course, considering that how these organizations work, there's actually a couple of things which also are interesting. The quality outcome is basically, there's a couple of surveys on this topic, and two key developer practices which usually influence the quality quite much is the version control activities and obviously testing and quality assurance activities. So version control activities are more or less simple things. So don't break the build, whether you have design or not, whether you have model or not, whether you have prototype or not. One of the important rules is that never break the existing build. Use log, communicate with other developers. And this is actually the fifth item here is actually something that echoes throughout the different practices and activities. Communicate with other developers. The prototype isn't useful if no one knows that it exists. Design documents are of no use if no one reads them. Models or plans or architecture models are no use if no one knows that they exist. Everyone is just doing their own design and what they were taught at the university or on their programming courses. So this is actually something that's fairly common problem. The communication and ability to gain access to relevant information at the correct time. Also, if we talk about agile development, because most of the world is agile development by now, because the plan-driven approaches are only reserved to industries which really need them, like aviation industry, space industry, or some other places where we are actually dealing with human lives. So basically, regardless of modeling practices and all the other things, the ideas are not very difficult. Keep it simple. Don't do the quick hacks. Write clear code, not clever code. Do automated testing and these sort of things. What is actually interesting is that from the agile development point of view, the amount of planning and design and modeling work before doing something that starts actually has decreased, because it's easier to test out your ideas with simple prototype and then start to expand from that than do a huge design and huge plan-driven approach, which will be thrown out first time we encounter something that makes following the existing practices impossible. But of course, this is something that's the modern times. For example, when I started doing my research work almost 20 years ago, agile practices were something that were just starting to appear, and actually people were very skeptical about the approach where we, instead of planning for weeks or months before starting the implementation work, doing the complete full model of the system before we start writing code, getting rid of that process or making that process something that we have a general architecture defined, and then we start to implement the first versions of the module and keep them simple enough so that we can actually see if they fit together and then start to do the more complex parts. This is actually, or start with the most complex module and start making that, and when we have implemented the first version of that, then start adding the more simplified abilities around it and select a set of core features we will implement first. Then we start to collect customer feedback and see how we want to further develop the product or the service, or if it doesn't if it doesn't gather enough interest from our customers, then keep it on low maintenance and throw it away if it doesn't start to pay its bills. But this is just the modern ways of doing software. So of course, this isn't something that's completely new. I mean, the ISTQB principles on quality assurance and modeling work and design for work and design principles are actually something that has existed even from the 90s. So basically, all these things we have already known way before we had a general access to internet. So of course, it doesn't matter how we design our software. It doesn't matter how we measure our software. It doesn't matter how we model our software. We will have complex components and we will have simple components. And because of that, the defects keep clustering, so 20% of the parts will contain 80% of the problems, for example. From the viewpoint of development work, of course, this means that if we do modeling work, if we do extensive design work before we start implementing something, it would be feasible to understand how complex different things will be. Find the most complicated parts, develop those first, or at least identify them so that we can actually focus our quality assurance practices on those. And this is something that modeling practices or measurement practices for the software industry come into play. So that's why the next thing we are going to be talking about is measuring software. So we want to do modeling work. And the idea is that if we do modeling work, we can start doing some measurement work. So why do we want to do measurement work before we have anything that we can build and deploy and try out? Or other way around, how is this going to save us money or resources or be useful from the viewpoint of software industry? So what is measurement? Of course, the measurement is that we need to have some systematic way of getting results and getting by defined rules, understand and measure what we can understand from the behavior of our system. So basically, we want the measurements to be something that helps us to understand how the system works. We want measurements to allow us to control how the system behaves. And also we want to use measurements to understand how we want to improve the system. From the viewpoint of modeling, of course, if we do modeling work, we probably also have some idea of how complex certain parts of the system will be. So it means that we gain understanding of how the system will behave, and it allows us to control, for example, our development process to focus resources on the complicated parts of the system. And also, perhaps, it also improves the outcome of the quality from our project if we understand what are the things we need to focus on the system development. So, of course, if we are doing large projects or something that's beyond the level of control and even comprehension of one person, we need to have a measurement plan so that we can collect the relevant information and understand how the system will be built, what's the current state of the system, and how things will be done. So, of course, to be able to do any analysis on how this, what's the next needs for the system, what are the things that we need to improve or work upon, we need to have data which we can collect and analyze. And of course, for example, in the process model for quality assurance and software testing, there are actually implementations and examples on how we can collect relevant information on software systems which are large or very large. These approaches also include things like doing modeling work, doing doing measurement work, creating a mathematical models, or doing complexity calculations on the systems or their behaviors or their explanations on how they are expected to behave. So basically, uh, because we of course need to talk about this from the viewpoint of software industry, it means that we have to have certain attributes on measurements. Like with the modeling in general, if we don't need to do modeling work, we don't do it. If we don't need to do measurement work, we don't do it. So of course, if we want to do measurements, there's a couple of things. So we need to have the ease of use for them. So it has to be something that saves time or money or effort if we create this measurement or metric, and it also needs to be understandable. It means that the organization has to be able to apply these measurements or metrics on making the product work better, or it needs to be something that helps them to identify what are the problematic areas of the system so that they can make new components or do re-engineering or development work to get rid of those problematic components. So basically, if we want to have a measurement, it needs to be objective, reliable, economic, and reusable. If it's not all four of these, then it's not worthwhile thing to do. So it needs to be accurate, it needs to save money or be economic to use. It has to be reusable so that the results are comparable, and it has to be objective so it doesn't depend on who did the measurement or where the measurement was done. So of course, these are just some basic stuff we can base our work on. And of course, from the modeling point of view, these are very simple stuff. But if we consider these other measurements, for example, these function point analysis, McCabe's cyclomatic complexity, or Halstead's software science formulae, these are something that we need the models for. We need to understand how the system is expected to behave so that we can actually do the function point analysis or cyclomatic complexity analysis to understand which components will most likely become the problematic areas, or calculate the software, Halstead's software indicators, which will tell us which are the components we need to implement and test first. And if those work, then there is not the rest of the system will be more simplified stuff. And if this works, then everything else will work. Also, function point analysis and general system characteristics extension on it are also useful for the organizations, not only when they are doing software maintenance, but when they are counting how many hours of work is needed or expected for this thing to be implemented, and not only on their own product work, but of course, if you want to sell your expertise to other organizations, you need to be able to understand how much work this will be. And of course, this function point analysis and cyclomatic complexity analysis are ways of modeling the system, modeling its behavior, understanding how much risks are involved, ultimately leading to the possibility of estimating how much it will cost us to implement this feature or create this module. So that's why these things are actually fairly much used, but they are a bit complex things, so I'm not going to be focusing on them on this presentation. So with this information, we have ability to know which things are complex and which things are not. So I'm finally, after 40 minutes of talk, getting into the actual topic of this lecture. So modeling and planning. So how do software industry organizations then do modeling and planning work? Of course, this is something that you already, most of you probably have seen. So UML2 chart types. These are the different ways of modeling the system we are building, whether it's its structure, behavior, or interaction, how it interacts and communicates with other systems. Of course, we know that this is something that's a bit of a 90s thing. This was designed by IBM to be something like doing programming work with graphics tools. And of course, the original idea didn't really work. But for example, some parts of this system actually stayed alive simply because they were very useful ways of illustrating information which was highly abstract and otherwise difficult to explain to other people. For example, the class diagrams or deployment diagrams or communication diagrams are basically things that we still sometimes see in the industry because they are very good at delivering the information they are trying to convey. Most of these modeling charts from the UML2 are not used because they are that important, but because they are something that enables developers to express their concepts and ideas on paper before they have developed something. So this is, of course, something that's also important to understand. We do the modeling work, and if we, for example, use UML, we use it because we want to do a design before implementation, because the system we are building is complex enough, or we have enough parties or enough developers, individuals in the project, that we want to actually have some sort of roadmap or architecture for the system before it exists, because that also ensures that we don't have to throw away done work because working hours are hideously expensive, especially if you get nothing out of it. Also, of course, this is something that we usually understand as what we are doing or what the software industry is doing. We have customers, we have users, we have requirements, ideas, and then we do some analytical design work, modeling work, maybe some UML design, some boundary and interface analysis. And then we start to do the actual architecture and define the actual components and start writing the source code. Of course, it cannot be, if I would say that this emphasis from the analytical architecture to the actual architecture, the paper design phase has faded away a bit because of the agile practices, because of some software industries and software organizations switching to agile or continuous practices where they start with a prototype, and if the prototype or proof of concept works, then start to build based on that a new system that they already know that this at least somehow will work. Of course, saying that the design work or the planning work or the modeling work before implementation hasn't gone anywhere would actually be lie, but still, if we are building complex system enough, or especially if we are building a software product line where we have core assets, and on top of those core assets we implement new features and make new products out of it, of course that means that we are still doing modeling work to a very high degree. So, for example, if we are running a company which builds cars or airplanes or whatever, or we are just a company which provides tailored software websites for different client companies, we of course want to have high amount of reuse, because not the cars share similar features, the airplanes share similar features, the websites, web stores share similar features, and also mobile apps, whatever they might be, might share similar features. So of course, the modeling work and design work and architectural models are actually something that's fairly common in this type of activity when we actually are making software product lines or offering products which are then tailored to suit the new customer segment or new client or the new implementation, the most recent release of our system. In most simple example, consider this as a way that we have a game engine on top of which the game studio builds the characters, the story, the levels, the game modes and stuff. So basically that's the product. But the underlying things, the core assets, are the game engine which runs the physics and other things. If we take this into one company and its internal product line, if we want to have separate core assets which are reused from product to product to product, and then we have tailored assets which are used in one or few implementations, of course this means that we need to have defined interfaces for the different modules. We need to have standardized way of connecting these things to each other. So of course, interestingly enough, if we go to larger companies which have product lines, which have reuse, which have core assets, the emphasis of doing modeling work and definition work and defining what the interfaces are, how the modules behave, or what can be reused from existing products is actually much more common than in the smaller organizations. And it's not only money issue, but it's also because their product lines might be built so that it's actually also much more convenient for them to define a set of Lego blocks, core assets, which can be reused again and again and again, and they are reliable enough so that you know that these services, these features can be trusted. We don't need to test them thoroughly again and again and again, just check that they were imported correctly into our most current project. So this is also something that's pretty much visible from the survey which we did on software organizations. So we did a same survey about software tools, software development tools and practices, having a high emphasis on software testing, but also asking other things in software organizations. On these following slides, there's data from 2009 when the agile practices were known but not widely used, and 2016, which was fairly recently, and things had already changed. Of course, you might notice immediately that the organizations actually in 2016 prefer individuals and collaboration and interaction over processes and tools, and also including design and documentation acts. So of course this means that the probability that the organization does highly plan-driven approaches has actually lessened to some degree, although transferring information by face-to-face conversation or documentation, this actually didn't change at all. But on the other hand, if we look at the factor, which is the second one from below, the progress of the software is more important than thorough documentation. The higher emphasis in 2016 obviously indicates that the idea is getting more features done and get the software out more than do extensive planning or modeling or design work. And when they are doing quality related things or maintenance related things or doing modeling work or doing measurement work, it's because they need to understand how the system works, for example, for the future maintenance perspectives. Also, similarly, the amount of testing tools or tools assisting quality assurance work has increased dramatically between the 2016 and 2009. Of course, this is by itself doesn't actually mean much, but it actually illustrates the point that relying on automation, relying on high iteration, relying on continuous models, and relying on prototype-based automation-tested approaches has increased massively during the last decade. Also, considering some aspects which are related to these things. Of course, something which was very interesting is that the feature development in late phases of the product design is actually something that no longer is a problem, because organizations, it wasn't considered that problematic in the first place, but this is actually something that changed somewhat much, because actually the organizations expect that there will be changes. They know that there will be changes. They know that their customers or clients will have new features, ideas, and want something new. So they have to be on the cutting edge if they want to keep their customers. Also, the amount of formal applications of standards and certifications have unfortunately started to crumble. The capability certificates and process model certificates are used much less than they were in 2009. Of course, this also means that the formal standards and certifications have a bit of a problem staying updated, and especially in the standardization process, the agile models or highly iterative models are something that are just recently making headway into actually international standards. And of course, if the standards are talking about plan-driven work and the people are doing agile or iterative continuous work, it means that of course they are not going to be applying formally the standards or certifications unless they are really needed for clients or because they are in the industry areas which still require them, like aviation or space industry or medical industry or energy industry or these other things, which ultimately are highly involved with human lives or national infrastructures. So in general, also, there is one thing that needs to be understood. So organizations, if they do modeling work, they do modeling work. If they do measurement work, they do measurement work. Whatever their quality assurance practices might be, the organizations don't really like to change how they do things. If it's not broken, if it's good enough, then it will be used. This is unfortunately the way organizations will work, and this is also the reason why some organizations which might actually benefit from switching to product line thinking and doing the modeling work and doing the design work and could reuse their existing assets to a larger degree, don't necessarily do that because it's extra investment of time, resources, and activities which don't directly benefit their products or processes. So this is why organizations don't do things. If things get really broken, then some small steps might be taken. And considering these two following cases, where actually there's two organizations which have had problems. The first one had problems fixing and verifying defects. The other one had problems with the other aspects of their work. But in general, if we look where we could put the design work, the modeling work, the planning work into these problems, there is of course the sales and requirements collection and insufficient requirements causing insufficient feature requests and so on and so on. But actually what was the problem here was that because they didn't have the design, they were doing wrong priorities, they were allocating their resources wrong. And of course, the ultimate problem was that one of the ultimate problems was that the quality was ignored. So they were doing wrong things in wrong order by wrong people and not caring enough that the parts they created were of high enough quality. Of course, in this situation, doing scheduling work or doing resourcing work or understanding what will be the most problematic or most risky components of our product would have been actually very useful information. So it means that in this organization, doing modeling work or planning work, which also involves architectural model to the degree where we can calculate complexity, from the function points, it would have been actually very useful for this organization. Similarly, on this organization, there were some problems that they had blocker type defects, which they had to fix before they could do anything again. So again here, they had a task backlog. They made too early customer promises. They didn't listen to their customers. They had insufficient requirements, and again, they had wrong priorities. They had lack of cooperation between the sales, testing, and implementation crew, and all the parties were missing information of what sort of system they are building or what sort of things are happening. So again, if they would have taken extra steps on the planning phases to do design work or modeling work to understand what sort of system they are building and sticking to that roadmap or architecture, this would have helped these organizations immensely. Actually, thinking about do the game development, for example, other example on workflows. So both these organizations or cases mentioned earlier had problems that they didn't actually understand or had problems on defining what sort of things they were doing. So, for example, how small app developers, like game developers, do their development work. This is just a quick thing to show you. They might not necessarily do the planning work or the modeling work to a large degree, but they actually do what they are usually doing is that they do prototypes, proof of concept tests, and then they test out the general concept or the idea, and then try to sell it or start to develop based on that. And if they have a small scale prototype, they can do design work, they can, based on the existing functional parts, design more things and do iterative development, or they can work with the proof of concept and show that it works and get a customer who buys for it or pays for the development and move further. So basically, these organizations might not do the modeling as a paper exercise, but they do modeling work and design work with the functional prototypes, which might not be as sophisticated for the long-term maintenance, but they are still doing modeling work for their designs by creating a prototype and using that as a basis for their product. And for example, if we look for 29110 standardization for small organizations, it doesn't explicitly mention anywhere that we have to do modeling work or the definition work, but on the project planning, there is, for example, the statement of work and project repository to which all the planning work and design work is included. And of course, this also has the idea that we are having a constant record on what has been done, what will be done, what sort of modules we need, and what sort of things we want to do. Because the most important part and most important problem in all organizations and almost all projects are that if we have more than a few people contributing to the same project, they don't necessarily know what they are doing at the same time or who is responsible for what. So for this reason, by itself already, we should do design work, we should do modeling work, whether it's the UML2 models or diagrams, or whether it's a functional prototype or whatever it is. We should have a clear view of what we are doing and create a roadmap, a module plan, or deployment plan, or component plan, or whatever, to understand what are the responsibilities of different components and how what thing is responsible for what feature, because ultimately when we go to the software maintenance phase, then if we are having problems with the system decay, then we know which parts we need to replace to combat issues which arise at that point. And finally, as a conclusion to this presentation, because I have now spent the 1 hour I was given, so the industry applies design and measurement methods they feel justified with. They are not doing design for design's sake or modeling because it's fun or create extra prototypes just to think things out. They do measurements to predict costs and to predict problems, predict resource needs, assess reasonable amount of work to get things done. And of course, if they do measurement work from the existing software or modeling work to understand which are the complex parts of the system they are building, it doesn't matter. These are the things they do because they want to predict and understand what's reasonable amount of work and what's the expected amount of problems they are going to face. They do prototyping, use proof of concept models, actual modeling work to set up product lines and reusability if they are at that stage. And whether it's design work, whether it's modeling work, whether it's prototyping work, whether it's route mapping work or whatever, the key aspect is that the organizations aim to have timely, available, and correct information so they can work with the product. See, because for the software organizations, the only thing that actually matters is that the things are done in budget, in schedule, with the intended features and with expected quality, because that's only thing that matters. They need to make money out of that. They need to keep their customers happy. They need to keep their clients, because they are not doing it for the charity, or they are not doing it as an act of kindness towards humankind, because they are doing business. They need to be prepared. They need to understand what they are doing, where they are going. And when they do modeling work, they need it's done to generate information which they will need when they are implementing things. So models, prototypes, measurements, requirements gathering, customer meetings, testing work, all tools, they are all tools to generate relevant and correct information. And this is something that needs to be understood. The academia and courses might show different crazy and different levels of detailed models and things you can do. For example, the UML2 diagrams have crazy amount of details you can add to stuff. But of course, the industry is not going to use that, because no one cares about modeling work for one module and its time criticality, unless it's a time critical module, for example, for the emergency air brake system in a car. So, or you need to have a real-time processor to process information coming from the collision sensors. That is important, but no one is going to bother with doing the huge model of system that actually doesn't need it. And this is the important takeaway from this lecture. Models, prototypes, measurements, requirements, customer meetings, working with customers in general, quality assurance, they generate relevant and correct information so that the software organizations can run their business and predict costs and other things which will affect how they work. Thank you. My name is still Associate Professor Jussi Kasurinen, and this was my presentation. Modeling and models and measurements in software industry. So if you have any questions, drop me an email, and otherwise have a nice day, and let's hope that the weather improves a bit. But anyway, thank you and goodbye.